Hello, everyone, and welcome back to NetApp On Air. Thank you so much for joining us. It's been a minute. I missed you guys. Have been getting things together for the last couple of months just to see as we head into Insight season. Yes, it's that time again, folks. It's time for Insight, so we're getting everything lined up for the show later this year, and we've been getting some of the shows, but we're back. We've got a great show ready lined up for you today. This is not going to be for everyone. This is going to be a little bit more of a specialist use case. And if you've seen the title and seen that stuff, you're going to know real quick whether this is for you. But I encourage you to stick around because some of the things we're going to be talking about today transcend what you can do with regards to AI, and some of the products that F5 have brought to market are pretty exciting. So I definitely encourage everybody to stick around, ask questions, and enjoy the content, regardless of whether you're doing this with an AI use case or not. Before we get started with that, though, I saw Drew had threw it up there. Let's talk about Insight real quick. Just a little bit of housekeeping, because early registration is open. So you have it until now, till the end of the month. When we hit July, the price is going to go up about $300. So if you want to get in now and you know you're going to be coming to the show, group rates are available, all of that stuff. You can save about $300 off your registration by registering early right now. Okay, you got till about the end of the month. When we hit July, I'm told it's going to go up about $300. So just a heads up for you guys. The dates also moved one day from what we announced last year at Insight. So be aware of that. It is now Tuesday through Thursday because I don't really know why. I'm assuming some scheduling snafus or something like that with the venue. But either way, just understand that there's a little bit of a shift in the schedule this year. We're starting on Tuesday, October 14th, and we're going through Thursday, October 16th. Whereas normally we would do like a Monday afternoon keynote kind of thing. What does that mean for our community warm-up party, you might be asking? Well, TBD. What I will say is we do intend to have one. We are unsure of whether it would be on Sunday night or Monday night during the event. So if you're making your travel plans now and getting everything set up now, I would just say try to plan on being there on Sunday, just in case. Just in case it happens, we will keep you posted the more we find out. It's June, guys. We don't really know the whole plan yet. So I just want to see everybody get registered. If you're going to start booking travel, keep that in mind. All right, so let's move on to our guest for today. I want to bring him on screen first and do a little introduction because we have two guests today, one NetApp, one not. And we've been talking about doing this show for the last couple of months and how we would actually spin it to you guys. And tell you the story of all of this, and because there's so many moving parts to it. But the first person I want to bring up is one of my teammates, one of my compatriots, Mr. Valkcamp. Win, you've been on the show before. How you doing, man?
Good. How are you doing, Nick?
I'm doing great. Thanks for coming back. And from what I understand, you've been side by side and a big part of this whole solution as it's been being built, yeah?
That's correct. That's right. Yeah.
What are some of your thoughts about it? Who are the key people that this solution would really benefit? Just as a quick primer before we bring Steve up.
Well, it's cloud engineers, network engineers who I think, but you're solving problems from my perspective, for the data engineers, data analysts, and data scientists to get access to a lot of data that it's right now it's kind of very difficult or impossible to get access to. For a variety of reasons. So, there's a lot of information and data stored on NetApp clusters all over the place around the world. And sometimes it's just difficult to transport them from some edge refinery or factory or some other remote site to get access to it. So opening this up to those data engineers, analysts, and scientists extracts and untaps, no pun intended, a whole lot of value in your ONTAP storage.
Gotcha. Yeah, that's a great way to introduce it. I was a former big IP customer 20 years ago. Like F5's been around for as long as NetApp has.
Yeah.
And I look at this as one of those kind of better together sort of solutions that have always worked. We used it for different web apps and things like that. But let's bring Steve up and get him on here so we can just introduce the man himself, Mr. Steve Gorman from F5. Steve, thanks for joining the show, man. Really appreciate it.
No problem. I was at Insight last year, and it was a great time. So I'm hoping to get the privilege of going again this year.
Yeah, maybe we'll have you on the show this year while we're on the show floor there. Let's get any updates you might have after today.
Yep, that sounds like a plan.
So, Steve, why NetApp? Why NetApp and F5? And really, at the end of the day, I want to make sure that people. I don't want to assume everybody knows everything about NetApp ONTAP and F5. What are you? You were talking. We were talking before the show, and you did a really good job of like laying out what are F5's big pillars and where they
Sure.
work in and stuff. Introduce F5 for me.
Sure. F5, I think in terms of age, is very similar to NetApp, late 90s. A lot of market share in where we play. We play in the networking and the reverse proxy market. So we're exposing key typically web applications, but it could be any application to your consumers. And when you go into a wiring closet in any country, you're going to see a big IP from F5 in all likelihood, and you're going to see ONTAP or maybe storage grid from NetApp. But quite often one is inhabited and managed by the NetOps, and you have storage admins taking care of the other product. But there's a bunch of use cases that I and Win have seen that we can bring these worlds together. And just briefly, I'd say F5 right now has three foundational technologies. One is the tried and true big IP server load balancer. At some point, we start calling them ADCs, application delivery controllers. So
they'll always be
years,
big IPs.
Yeah, exactly. A number of years ago, we also acquired NGINX. So a lot of people know NGINX as a open source web server, but we have it as a product and does a lot of value add like a reverse proxy. And then in the most recent pillar would be distributed cloud. And distributed cloud at its heart, it's just like a big IP. It can be an ADC and expose your apps to audiences. The key difference is it's multi-site. So I could have apps inside an Azure resource group. They could be in a private data center. It could even be a Kubernetes service inside AKS or EKS. And then I'm going to expose it to clients, and I'm going to have a lot of fidelity here. I can expose that service to the entire internet through our distribution network, or it could be delivered to a partner in their Kansas City office or in their Frankfurt data center. So we can talk in detail, but it's basically distributed load balancing, and that's the distributed cloud product in a nutshell.
But it's also, you guys are managing that distribution. Is that on your own backbone? Is that fair?
Sure. So in a world of a big IP, it's very simple. If you think of a box, you have an inside with origin pool members. So maybe I have 12 web servers, and on the outside, I have a virtual server. A lot of people call that a VIP, or they'll just call it an application. They'll say, I have 3 or 4 apps on my big IP. With the distributed cloud, we can take it up a notch. We can have the origin pool be multiple physical locations. So maybe a web server in Azure, a web server in AWS. But when we expose it, it's not a box, an interface, a virtual server. It can go right over any cast through the globe. We have about 28 metro markets where we cover, and through the magic of BGP, we can basically say this app, this virtual service maps to one single unicast address. And if you're in Perth, Australia, you're probably going to come in through Melbourne or Sydney. If you're in Brussels, you're probably coming in through Amsterdam or Frankfurt. So we do have quite a large fabric. I call it a fabric. If you took all the links that interconnect this private fabric together, it would tally up to around 16 terabits per second. So it's a pretty big global network.
Nice. And I'm assuming the adoption of this new distributed cloud has been fairly robust.
Yeah, one of the big claims is it's a SaaS offering. So kind of like maybe a Blue XP would attract a new kind of audience. You're dealing with a single pane of glass. And I can provision connectivity to apps that are in Google, Azure. They could be in a private data center. And it's always the same ClickOps. And we also support things like Terraform. But for people who just want a simple way of providing connectivity, it's there. And then we have a universal WAF engine that runs on all of our products, Big IP, NGINX, distributed cloud. So we have a lot of different signatures and bot detections and malicious user detections that are uniform.
Awesome. Yeah, it's one of the, so I use reverse proxy myself, and it's one of the main reasons is 1 for certificates, and 2 is it's almost like a secondary firewall in a way to where it can choke off any malicious intenders without having any kind of access behind that. So it's really smart to do that kind of stuff. So for people that are currently F5 customers, is like if they have a stack of big IPs in their data center, is this something they can take advantage of today? Is this a separate product line? Like, walk me through that. Like, if I have an existing box already, can I turn this on?
Sure. So, for instance, if you have a big IP today and you have something like a storage grid cluster, so it's an S3 object solution and it's a clustered technology, it's a perfect fit. We can basically treat each of the data nodes in storage grid as an origin pool member, and we have, I think, 13 different load spreading algorithms. So this becomes somewhat important in some AI use cases like model training, where you need to move a lot of data and you need to move it in a hurry. Using an external load balancer is very popular. And it's very rapidly evolving, but one of the more recent ideas has been the rise of post-quantum computing, PQC for SSL. So F5 has always been very, very strong in SSL interception. We can decrypt, apply security. We can even route traffic through an IPS IDS if necessary. But we now have the ability to start dealing with quantum computing resistant ciphering. So this is something that could be very useful, because in the industry, one of the fears is a concept of harvest now, decrypt later. If I can store enough of your high value data, and in 2030 or 2035, quantum computing actually matures, I could retroactively go back and try to decrypt your traffic. So there's an impetus to start using quantum resistant basic TLS mechanisms now, and you can do that with a big IP today.
That's fantastic. That's actually the first time I've heard about that. Thank you for sharing that, because I was wondering where quantum was going to start showing its face in the cybersecurity world. That's that's interesting that we're talking about 10 years from now. Retroactively going back and decrypting stuff to be utilized 10 years from now.
To be honest, it's why some of the messaging like Telegram and iMessage from Apple have already gone to post-quantum or quantum resistant TLS, is to avoid someone looking at what they thought was secretive. And actually, it's really coming into play now, because NIST had basically took under consideration all sorts of algorithms, but they've now chosen a few. There's one you might have heard of, FIPS 203, there's FIPS 204. So the industry is standardizing on a bunch of algorithms, and F5 is already making this available on our big IP platform.
Fantastic.
And NGINX.
Well, that's a great example. So we talked about the people that might be customers already and if they could take advantage of it. Before we get into the meat of the talk, like, what is the best way to get started? Where can people find something if they're not an F5 customer currently? Is there a logical place to start if they only want to use distributed cloud?
Yeah, in terms of distributed cloud, it's a SaaS offering. You can basically trial this product. For the use cases that we're talking about in today's session, I've been collecting a bunch of technical articles on our Dev Central site. Dev Central is basically it's for ideas and for almost like proofs of concept for the mind. So I've written a number of articles that use elements of NetApp and elements of F5. So we have one link that takes you to all of those relevant articles, and probably would be a good starting point. But I think AI and the ability to get RAG systems and MCP systems together, where the data is not where the actual LLM is, the data is in a lockdown address 10.xxx private IP data center. This is really where I think the most momentum is. So that's where I was thinking we might talk a bit about these solutions today.
Yeah, and Win, I'll throw it back over to you. Same question. So for people that might be looking for this kind of stuff, maybe not directly from F5, like, we know ONTAP has a built-in load balancer, but that's not necessarily what it's derived for. It's not meant to load balance external web applications like something like big IPs can. So where do we guide ONTAP users and customers in this sort of conversation? Where do we tell them to get started?
Well, where Steve and I have been working together a lot is on distributing these S3 endpoints. AI uses a lot of it almost exclusively uses object storage. ONTAP supports S3, and you can light up your existing NAS volumes with S3, just this multi-protocol, add to it, and then of course, ONTAP is the cluster internally is distributing the data, but there's going to be an S3 endpoint that's going to be presented from ONTAP. But you're going to have all these different clusters around with all these S3 endpoints, and F5 can unify that, can distribute that across wherever it is. So it's kind of I think the easy button from a network perspective on how to get to all these endpoints. So you can just give your URI endpoint to your data scientist, analyst, engineer, whoever wants access to that data, and then they just plug it into their code, and through the magic of F5, it can get there.
It's going to pull in everything that the big IP has access to effectively, right?
That's correct.
The F5 stuff has, yeah. So that's cool. So they're not just hitting one particular storage system; they're hitting whatever is behind that. So they don't have to care about the storage stuff behind the scenes. They hit an endpoint that's doesn't matter to them whether it's an SVM or whether it's an F5 big IP. That's what they're hitting, but they're getting all of the data that's been collected behind it collectively.
Including software defined. So, ONTAP Edge running. Of course, that's what we've been doing a lot of testing on, actually. And but on-prem, cloud volumes ONTAP, all of that, anywhere you need it. This can be very, very handy. There's a lot of big organizations, I think oil and gas, that operate in very remote areas that don't have access, honestly, to the nearest cloud region. Might be United Arab Emirates or South Africa if you're in West Africa, but they have a lot of data that they need to get access to that's not easy to transport. So this brings the kind of the algorithm, the query to the data there, and be able to catalog it and inventory that data, so you know what you've got.
That's fantastic.
Yeah, it's very handy.
Steve, anything we missed there you wanted to cover before we jump into the presentation?
I think that's very good interpretation. Thank you, Win.
Win's a smart dude. We've had him. We keep him around. What are you at 20 years yet, Win?
20 years, August. That's right. 20 years.
Yep. There's a few of you left.
Yeah,
you and Toby and Mecca, and there's a few of you.
Yeah.
All right. Well, let me pull the slides up here real quick, guys. Hang tight. We're going to go through a couple of slides, and then we're going to show a demo, and we're going to talk more about it as we go through this stuff. Steve, I'll just hand the baton to you and take it away.
Sure.
Do you want me to build this all the way out for you?
Yeah, why not? Go for it. Yeah, just build it out. So what we have here is a use case. This has been built up in reality and documented where you want to use some AI that you want to host. So we're talking in that green bubble. Typically, you're going to have some Linux boxes. You're going to go to use Python, grab from Hugging Face some models. You might also use something, you might do LM Studio, you might do Olama. But the point is, there's a place where you're running this. And this is a diagram, the green bubbles in Los Angeles. The CE is a piece of hardware or software from F5. It's called the customer edge. And it lets the inside interface of that CE, which is touching that green bubble, be the point of consumption. And what's being consumed are in those purple circles. Those are NetApp volumes. So we have examples of volumes in the data center in Seattle. We have it in Denver. We also have NetApp in cloud, Azure, AWS. And what we can do is we can do a couple of different techniques. One technique is to deploy a distributed load balancer, as mentioned before. So the origin pool would technically be any of those NetApp sites. So if it's NFS or it's SMB, it works with a TCP load balancer. But if you take your ONTAP and turn on the S3 license to project those files as objects, that can be a layer 7 HTTPS load balancer. And basically the virtual server, to use the nomenclature of a big IP, by what I call the publication of those apps, those NAS protocols. The publication is the Los Angeles CE inside interface. So it lets me mount on that Linux box where I'm running my LLM. I can mount volumes, NFS mount -t commands. And the second application here is how do you expose the AI interface, whether it be something like a Jupyter notebook or it's a chatbot. How do I expose that to my users? Well, that could be a layer 7 load balancer, and the consumers are in that black circle, and those could be on the internet. So that could be basically the service, the web interface to that LLM box is going to be projected as an Anycast address around the world to any of our REs. So those are really two different use cases of the distributed cloud. One is for kind of the back end, bringing data, making it accessible to the LLM for RAG, so it can be indexed. And the second use case is to expose the AI interface for users of the AI system, which are in the black circle right there.
So quick question for you, so I understand like the cross cloud provider usability of this, the value of it. What if somebody's just all AWS? Doesn't AWS, doesn't Azure, doesn't Google Cloud all offer this kind of sort of backbone service already? Is this really for people that want to be multi-cloud, or is there some additional value add above and beyond like what the native cloud providers offer?
Right. So let me give you an example. Let's say I'm all Azure and I have Azure VPN gateway. So I have site-to-site layer 3 VPN. I would say that it's probably not as attractive if I'm 100% Azure, but that's really just all typically a connectivity solution where if I'm doing S3, where is the web application firewall? Where is the rogue user detection? Where is the anti-bot? So distributed cloud is giving you not just multi-cloud support and a single pane of glass. It's also giving you a lot of security that's layered on. So it's a network and security play.
Yeah, it goes higher than layer 4, like you would typically get with like a link light, whatever data layer you're going to be at with the native services, the native VPN connectivity. Like you're missing out on some of that higher level application security that you guys are providing.
Yeah, and I want to point out one other real key feature. What I've been describing is a distributed load balancer, whether it's L4 or L7, depending whether it's NAS or whether it's S3. And that's very useful, but there are times such as SnapMirror where I actually want to have NetApp to NetApp for SnapMirror replication. Preferably what you want there is a pure layer 3 connectivity. So we have a mode called Network Connect. And if you look at all the CEs that I've deployed, and the CE technology is Kubernetes based, it's the exact technology of the RE. Most solutions in the internet, there would be like the provider technology and the edge technology. It's the same technology. But if I turn up a CE in 20 sites, I can have them boot up, dual attach to the closest RE. So if I'm in Belgium, maybe I attach with IPsec to Amsterdam and to Frankfurt. It's all auto connect. You don't need to know what an IPsec SA is. You don't need to understand IPsec. It turns up, it dials in. If there's a problem with IPsec, it'll use TLS. But this gets even better, is they auto discover each other with a few clicks and set up a multi-site to site VPN. So all of my 20 sites, the inside interfaces of my CEs can all talk to each other. I can ping servers in any of the other locations. So that's layer 3 mode, and it's called Network Connect. And I've used that quite often with SnapMirror use cases because SnapMirror doesn't like things like NAT, doesn't like going through load balancers. So
it's almost like having a management interface on your networking gear. Like you've got a management network of sorts behind the scenes. I like that. And
if I didn't mention it, you never touch a routing protocol. You're saying, well, what about the route tables? It's all part of the SaaS mentality. Boot, dual connect, and that's active. So you'll get the bandwidth kick from both of those connections to our RE POPs. And then the routes are taken care of by themselves. If you need to do a SNAT option, you could, but basically it's very, very easy to set up site-to-site VPNs with many, many sites using that technology.
And is F5 managing the BGP configuration and stuff like that on all of these as well?
It's now you can come in and you can, if you want to go to the next level, you could peer that CE so that you bring in more routes that will get automatically propagated. But I guess it's a long way to answer your question. It's a simpler experience for the end users. You can, I believe you can do more with less technical debt, I think is the term. Also, just one last one. Let's say you are just an AWS shop and you really understand AWS site-to-site VPNs, but you do have to get into Azure because you're an independent software vendor. Your wares are what you're trying to move. And you have a consumer who says, unfortunately, we don't deal with AWS for our own reasons. We only deal with data on Azure. You can get your data, you could replicate to Azure or replicate to Google without going and learning those layer 3 VPN technologies. I don't have to train myself. It's the same workflow on any of the hyperscalers.
Yeah, and it sounds like that you could facilitate data transfers between ONTAP and ONTAP in either of the cloud providers.
Yeah, we did a pretty good study on using BlueXP and our Cloud Manager. I don't know when it slapped me. I call it Cloud Manager, but I think the names could be somewhat fluid. And it's
a couple of years ago we changed it. Yeah,
that's right. Yeah.
Because it's SaaS first, and it's very similar. It's cohesive. People who are traditional NetApp users who understand System Manager and the CLI, they can take a load off and use that SaaS approach to doing replications. And then one thing that I really like in the world of AI is, okay, I've replicated to Azure, Google, or AWS, is I can do a clone. I can get a read-write copy of my data that doesn't cost me anything in terms of storage from the moment of inception. And I can start doing my data science projects on that clone. So there's a lot of interesting use cases.
I mean, you could even have your development or unit testing or one thing in one cloud and your actual production in another cloud. And like I look at use cases like that. I see that quite often because they'll use something like Azure or virtual desktops for end user workstations, but maybe they run production web services out of AWS.
Right.
That's one of the typical use cases I see people doing.
Yep.
Another use case I can think of is I see this quite often is partnerships or joint ventures where there's between business to business and they're sharing like large oil fields, for example, are rarely operated by one oil company. They're a joint venture and they have to share information on exploration. And it's very complicated to get these shared environments set up because you got company A and company B and maybe company C, but they all need to have access. But they each have components of things. Media and entertainment's another one. Healthcare is another one. And company A may be entirely operating in Azure. Company B may be entirely operating out of AWS, and company C may be entirely on-prem. Interconnecting that is a nightmare, and getting that and cloud teams, infrastructure teams, that's something they wrestle with quite a bit, and also getting access to outside external data sources like banking, and being able to transport that data if you need to do queries. You get access to it, but you got to be able to build the link between the two. This could go a long way towards making that a lot easier.
Yeah, former federal contractor here. I could see the infinite use cases that all of the agencies might want to use with something like this. Military, especially FOBs and things like that. You said media and entertainment as well. That one really struck me because most modern DAWs or editors have some sort of built-in cloud collaboration mechanism now. At least in the last 2 or 3 years, I've seen most of them, whether it's DaVinci Resolve or Premiere, or I don't know if Final Cut's got anything like that, but we're talking about big post houses. I know Avid does, which is the gold standard of all like post-production houses. So I'm looking at this going, you can have editors all over the world now collaborating on a single edit, single timeline over a network like this without having to buy some super crazy subscription from one of them. Or depending on them to provide that. Now you have a reliable enterprise networking solution, global sort of load balance distributed solution that's protected, all of that stuff. I think media and entertainment should pay a lot of attention to this kind of stuff.
Yeah. That's
Even
good.
for staging game deployments, there's all kinds of use cases that you could get around with this.
I remember many years ago when they were talking about when they were making the Star Wars prequels, regardless of your opinion of the Star Wars. But George Lucas talking about how they had to pull fiber because they wanted to shoot, they wanted to get that started into editing like immediately, and they paid a lot of money to get network connectivity out to Tunisia, in the middle of the desert where they were shooting. This might facilitate and make that a little easier. You have your last mile issues, of course, but this would certainly make it a much easier prospect.
Yeah. All right, Steve, anything else on this one, or you want to move on to the next one?
No, I think that's good. I mean, there's so many things. One last thing that comes to mind is if you're doing S3 availability, we're user aware. So if there's a user who's biting off more than they should, basically abusive of the number of transactions, we can do selectively throttling. So we can send an HTTP 429 message back saying, too many requests, you've exceeded 50 requests in a minute. So that would be another use case of getting more mileage for the buck out of your storage grid is by implementing rate limiting on S3.
And is that a knob that you can dial into whatever you really want to?
Exactly. It's different endpoints could be unaffected by that, and certain key endpoints could have very aggressive rate limits. Just one more stream of consciousness kind of thing, but let's say I have it's a web service, but in the nation of Fiji, there's traffic should not be coming to the global instance. It should be in country. We have geo-IP rules. So we can say, hey, to get to this S3 service, unfortunately, Fiji, you go this way, the rest of the world goes this way. This is the kind, and there's just a multitude of these security aspects that you probably wouldn't get with your vanilla site-to-site VPN solution from one vendor.
Yeah, data sovereignty rules. Data sovereignty rules are a big deal in a lot of. I think Malaysia is another one that you can't export data out.
Germany.
In Germany, that's right. Germany has its own cloud thing. So
we have a use case where we have an EU user and they're traveling in the US. So when they would connect through New York City or maybe Ashburn in Virginia, but we can make it such that the actual SSL interception, which is really what you're concerned about, that's where the security is. That's where the deep visibility is. We can make that happen in EU. So that could be a use case around data sovereignty.
It just becomes a trace hop at that point, and you're carrying it over to wherever the destination is. That's cool. I really think that's understated a little bit, if I'm being honest. I think that's I think data sovereignty and the security aspects above and beyond like layer 4 that you guys are providing are the value here. Not necessarily that you've created a sort of global distributed network, but the stuff that you're doing above and beyond that is the real value here. Wynn, I wanted to ask you one more, maybe both of you. We talked about storage grid, but ONTAP has S3 too now.
That's correct.
How does that fit into the picture here? Is the same stuff available in there, or are we depending on the native load balancers in ONTAP?
No, same thing applies. Of course, once the data gets into ONTAP, it's using its own load balancing and S3 buckets. Let me back up. ONTAP has two kind of modes of operating with S3. There's NAS buckets, which is you're adding S3 to an existing NFS SMB volume. And then there's S3 buckets, which is just purely S3. When you deploy an S3 bucket, it deploys a flex group for you, and it kind of manages all that under the covers, grows it, shrinks it. It's very, very nice. But the abstraction here is the S3 bucket. The S3, the API is universally accessible, and you don't.
Yeah, but is the bucket the endpoint that we would connect to with this? Okay,
that's right.
So we're not using the internal load balancing mechanisms of ONTAP across the buckets in any way?
No, that's right. Okay. No, it's just the internal for all the flex groups and where the data gets loaded, but that's abstracted from you. And where F5 is on the front end, it can distribute that to all these different S3. Each SVM is an S3 server, and then there are buckets associated with that. So that's your root URL, and then the bucket is the remaining part of that. Yep.
Awesome. All right, let's kick over here. And Steve, I know you said this was the other one you wanted to go over.
Well, to be honest, I think we've this was just a little bit how the sausage is made slide. It's a little bit more on one use case where basically in the red box, we have the two functions that F5 is delivering with distributed cloud. One is basically giving you remote access to your users through our international global network to get to the Jupyter notebook or to get to the web interface to do their AI task. Number two is basically in this lab that I built up, we're basically using the layer 3 methodology to bring traffic from an ONTAP. ONTAP Select is in the Redmond, Washington lab, and we were bringing it up to Azure to a resource group, a VNet within a resource group. And that basically is done by creating a mount, a NAS mount. And then in the article, I went on to basically vectorize data from a bunch of different folders and volumes in the ONTAP box. So I think we pretty much covered all that.
Mm-hmm.
So one of the things that we pitched this show to be about, this episode, I should say, about AI and cloud. I don't want to not talk about that in any way from a solution and a use case perspective. We've talked about like the fundamentals of the distributed cloud itself and how all of that works, but like for the AI heads out there, where does this really like benefit them in a big way? What are when you have these LLM inferencing use cases using RAG across multiple endpoints around the globe to bring it all into one main model? Like what's the sell here?
Yeah, I'll give you one example. It's to make basically an empowered support desk worker where they need engineering, they need some of the knowledge that's contained within release notes, within engineering specifications, within user manuals, internal KB articles. And if you're a distributed technology company, that resides in some probability on NetApp volumes in multiple locations. There's no appetite or regulatory advice to move that into the cloud. In this example, you want to reach in and just get remote access to it to empower the AI decision making, so that when someone asks a very complex question, which might be above the skill set of the operator, they can have an empowered response. So what we're doing is RAG basically carburetes your data, all the PDFs, all the docx documents with the knowledge required into small chunks, and then basically a semantic meaning, an embedding model will assign it a vector. So the vector typically is over 700 or 800 digits long. It's got a direction to it pointing out into space as it's usually depicted.
Yep.
And that's kept in a vector database. When the inference comes in, the operator types in the user's query. The very same embedding LLM creates a vector on your inference, on your question. And using semantic similarity, we try to find 4, 5, 6 chunks in all of your data, which is originating in all these different sites around the world, that are coherent with it, that are aligned with it, are semantically somewhat similar. That's given to the main generative AI LLM as sort of hints. We call them augments. That's why it's augmented is the A in RAG, and basically the LLM can come up with a better, hopefully can come up with a better, more meaningful response, because it's been infused with basically paragraphs of data from all around the world in your data sites. I don't know if that's kind of helpful in any way or leads to more questions.
Absolutely. No, it leads to a bunch of other questions. When I was going to throw it over to you and ask, like, how have we built this with some of the team work that your team's doing with you and Sabu and Will?
Well, yeah. So, I mean, if you think about it, if you got to get to the data one way or the other, right, to make this work. So the data is out kind of at the edge or at a remote site. The vector database is and the engine for the RAG is maybe centrally located somewhere else. You're either going to have to go out to get the data so that you can, or you're going to have to move that data in and pipeline it in. That's a very expensive, time-consuming operation. Data pipelines can be expensive, but that's one where you're not talking about tiny amounts of data. It's massive amounts of data. So you're gonna have to build a whole inference, maybe we snap mirror it in. There's a whole, well, it would be a lot easier if we could just reach out and touch that data and vectorize it, and then the LLM reaches it over the network and then it stays in place. It removes a lot of governance issues like we talked about earlier. There's no wait time. We can use ONTAP S3, just light it up. I may have kind of undersold the importance of lighting up S3 on your existing NAS volumes eliminates an entire class of data pipelines. you don't have to do it anymore, which means all the costs, all the wait time, all the infrastructure, compute, network, storage infrastructure to get that data pipelined into wherever you're trying to go, it goes away. And that equates to potentially millions of dollars a year. This is another one of those where F5 is enabling you to get to the data without having to move it with all the risk and cost involved.
Yeah, that's huge.
Yeah.
Well, Steve, I understand we have a video. I want to make sure we had time to watch that to show the actual demo here.
Sure.
Anything you want to say to set that up before we jump into it?
No, if we just play it, maybe we can speak to it. I think the key value is you would see the very, very simple configuration from the F5 distributed cloud, how we build, and it'll actually do a demonstration where we do RAG with NetApp gear.
Gotcha. Remind me, was it 2 or 3?
2.
2. Got it. All right. So I'll let it play. It's muted right now. I'll just let you talk over it. If we want to pause,
sure. It's
let me know.
Just as an aside, we have a show like Insight. It's called App World, and ours is strangely enough, was in Las Vegas, but a different hotel. So I showed this demo on one of those big screens at our version of Insight. So that's why you're seeing some words go by. Basically, the first minute is just a recap of the architecture. While that's doing it, another architecture that I recently did was using FSxN for ONTAP using AWS, where the LLMs are in a private VPC, or access to the Bedrock LLMs are in a private VPC, but we drop a CE node in there. And then with FSxN, we start doing snap mirrors. So we actually start doing data protection volumes in FSxN. And that's where the consumption of the vectors can happen. So there are many ways to do these architectures, but in that case, distributed cloud is giving you private access to your private data centers that are on those 10 or 192, 168, 200 networks that are not available to the world, but we can securely feed snap mirror sessions into the AWS environment. There's a similar Google play with Vertex AI. So this is by far and away not the only way of doing it, but it's one that I recently wrote. So this it's a bit small, but basically what we're doing here is we're bringing 3 objects from San Jose. They're on storage grid. They're actually behind a big IP. A big IP has some value there, but it could be done without the big IP. And we're going to do some inferencing in Seattle. So this is the SaaS interface to distributed cloud. So it's a bit different than the big IP TMUI that you might have remembered from 20 years ago. But basically,
it's basically the same thing.
We're going to give it a domain name now. If this was a live service going to the internet, you can give us your DNS rights. We can do the NS records for any domain that you might have bought on Route 53 or from Google Domains. But this is an internal use case from one internal data center in San Jose to another internal data center in Seattle. So we're using a private DNS. Always, a demo is private DNS when somebody ends it in .internal. But what we're doing is HTTPS, because this is S3, and we have an Acme V2 solution that's using Let's Encrypt. So we can spin up an actual customer accepted cert instantly. Or you can use, in my case, my own certs that I created in OpenSSL. And now this is where we're tying it to the origin pool. So the origin pool is going to be located in San Jose. So this is the key. It's not in the same place where this service will be consumed. It's in another location in San Jose. And you can see I'm giving it the IP address. It's a 10.xxx address. So it's a private address. This is storage grid. We could do SSL offload and talk to it without SSL, but we'll do SSL on both sides of the service. And at that point, you basically have yourself a distributed load balancer that's tying together 2 sites. And we're going to turn on, if we want, web application firewall, and we can turn on API protection. So if I see something in the API traffic that it's supposed to be JSON, but it's actually a JPEG file, we can actually block that. So we can do content-aware API security, as we're an inline solution. We're not an out-of-line solution. We're an inline solution. And then this is finally the most probably the most important screen is where are we going to project the service? So the service is not going to go to the internet. The service is going to the inside interface in Seattle. Once I'm in Seattle on that LLM Linux box, if this was NFS, this is the typical way I would grab my data to start doing the garburating, the chopping and vectorizing. But I'm using the Fuse approach. So with Fuse, you can actually use S3 and user space to do the same sorts of remote access. I'm going to grab a couple. I need at least 2 LLMs. I need an embedding LLM to do the vector creations. And I'm going to need an actual generative text LLM to do the actual answering of my inferencing questions. So in this case, you can see I'm using Nomic Embed as the embedding LLM. And this just demonstrates that I'm sitting in my Seattle office using S3 browser, which lets me visually verify that I can get to my remote storage grid buckets. And as you can see, it's working. Otherwise, I wouldn't be showing you the video. But just as an example, the example I'm going to show is you probably have a lot of consumer devices that are aged out in your house, probably about 4 digital cameras, maybe some blenders or air fryers, but you have a bunch of paper documents for the manual. So the idea here is I've made PDFs of a bunch of household devices. I'm going to ask a question about a lawnmower. This is coming right out of a PDF document, the user manual for this lawnmower. So by asking this question, the response is using the files that are on storage grid in San Jose, has found that there's a chunk. It even tells me what page in the PDF says, the concern about this lawnmower is the heat of the muffler. You probably need to keep away when this thing has been running for a few minutes. So it's a very, very simple example of RAG, but it's conceptually the same concepts that you would be using for financial industry or medical devices, medical appliances, is basically bring that secured data into the equation, empower your LLM to consider lots of different sources when it formulates an answer, and it can give you a meaningful answer at that point.
Nice.
That's basically the gist of the demonstration.
Awesome. We did have one question come in. Let me pull this down on the screen here. What is XC?
Yeah, XC stands for distributed cloud. I imagine calling it DC would have caused a world of hurt because so it stands for distributed cloud. That's what it stands for. It's basically, if I had to explain what it is, it's the addition of, it's a global network of sites that are running an intelligent L4 to 7 solution that's Kubernetes based, and you can expand it into your VPC and into your data center by using a CE, a customer edge instance of that. It can actually run inside Kubernetes clusters, so you can actually run it as it's a pod, a container, and then you. I was
going to ask, is it like Cloudflare D? Is it just a little instance, kind of a reverse instance?
I wouldn't call it a reverse proxy just because that would eliminate that smart network connect mode. I would just call it a smart layer 3 to 7 Kubernetes based solution. And the keys are that we'll give you a secure global network that we've built up with those 16 terabit per second. That's not one link, that's all the links. And why that's very important also is when you use Anycast and you get to talk to a node that's close to me, the TCP flight times become very low. You're going to be able to get to a larger TCP window more quickly if you have a slower time to get to. I use Montreal and Toronto as my points of ingress, and also the fact that I can take the technology and turn it up as instead of being an RE, I can turn it up as a CE, which is customer edge in my own office or inside my own Kubernetes clusters.
Nice. We did have one more. Thank you for the question, Tangzel. And thank you, Steve, for the answer there. We had one more video we wanted to try and sneak in. Do we still want to try and do that?
Could you go for number 3? I think it's good. It'll give you the warm and comfortable feeling of big IP, and it's using big IP and how we use it with. Again, in this case, it happens to be storage grid. We're going to be working on some big IP plus NetApp collateral soon, but. What we want to do is, in this example, we want to be able to read and write massive amounts of data. And a typical use case for that would be in model training, which is not going to be in everyone's bailiwick, but it is in some key institutions that are building their own models. The world is basically accepting S3 because it's multi-threaded. There's concurrency with HTTP that doesn't exist so much in SMB world, where it's more of a serial set of operations.
Yeah.
It takes longer basically to move files with SMB for things like opportunistic file locks. There's a lot of control plane activities that are sequentially done. S3 goes like fast. And with this, we can use something like the big IP, which has been doing web reverse proxy for 20 something years. And we also have that ability to do lots of high speed SSL interception. We also have hardware assist. So we do have an FPGA when you're using one of our modes called fast L4 mode. We can actually harness hardware and FPGAs to go even faster. So one of the nice things about this is that we have a lot of built up security features. So you might recall iRules, where we can write some like Tickle TK. It's like Tickle scripts that manipulate the data plane and at very, very high speed. We can do API authentication. So this is the TMUI. I think it's like System Manager. It doesn't change quickly. So Nick, if you used an F5 big IP, you probably...
This looks very familiar.
It looks very familiar. So we can see that we have an origin pool of 3 nodes. And if we jump into the storage grid manager, we see those 3 nodes. So at this point, all we really need to do is build a virtual server, or as I've said, some people call this define an app. So we're going to give that a name. We're going to give it an IP address that's on the outside of the box, sort of projected to consumers. And we're going to use port 443. We're going to do full SSL interception. We're also going to repackage it up as SSL for storage grid. You could do an offload, get somewhat higher performance on your storage grid, perhaps, if you did offload. And at this point, we're just going to use, we're in the data center. We're just using that same browser application that it's called S3 browser. And we can just peruse the different buckets that are on storage grid. I'm just going to quickly download a bunch of objects. They're files, but I guess in the S3, they're really just objects. And if I go into my Windows browser, I can see, lo and behold, there they are.
Wow.
So that's basically in a nutshell. I want to show one more thing here is let's look at the origin pool members, and you can see that there really was a load balancing operation. It's a bit hard to see here, but you can see 2 of the 3 data nodes got utilized in that demo. So one of them was idle and 2 were used. So it does prove that there's a spreading of the traffic across the cluster.
So I'm looking at that as a use case of if you have buckets that are spread out all over the place, whether they're individual users or individual sites or individual assembly lines or whatever they're used for, this can be used. They can be added to a pool that can be used to ingest into a central location for inferencing, for example.
Well, yeah, in that particular demo, that really is a on-prem. It's not really a multi-site solution. It's really designed for people who need to go very, very fast. So if you're basically trying to feed GPUs that are building a model, they need data and they need it fast. So you might have tiered storage. So tier 1 is, block-based, very, very high-speed technologies, but it itself has to be fed by another tier where the S3 objects are. And that big IP can allow the movement of S3 objects at higher speed than an individual node would allow. And like I mentioned, there is a hardware assist mode called ePVA, which can make it even go faster.
I remember it was one of my favorite pieces of gear to work with.
Mm-hmm.
And that was 2008.
Yeah.
2007 maybe. And all we did was we had a single web app that was used across the country, hospitals across the country. And we had one IP that basically we pointed our application at, and that was to the big IP. And inside of the big IP, we had the pool, and behind the pool, I had virtual machines that were very stripped down, standardized, perfected templates of web servers. And I had a script that I would run every time. And we got to this point where it was automated, but we could automate the pool based on load.
Mhm.
And I can't remember exactly what rule we were using, what load balancing algorithm we were using,
Right.
but it would
Yeah,
stand up
some of
additional
our-
nodes automatically, kind of how Kubernetes does. Before
Right.
Kubernetes
Yeah.
was Kubernetes, we were doing that automation.
Quite often people use least connections. So at any moment in
Yeah.
time, whoever is holding the least state, the lowest TCP established sessions, they get it. That's kind of the typical one, but there's actually 13 different algorithms. And just one last note, if you're a big IP only shop, and you're not a distributed cloud shop, you can do multi-site. It's a GSLB. So if I have 4 data centers around the world and they're filled with web servers that are mission critical and I have big IP in front of each one, we have a GSLB solution that will point you to the best one in terms of cost. And if that whole site goes down, the GSLB has health checks. So health checks are looking at your origin pool members. And if it sees this is really a site that's suffering, it can redirect traffic based on health check information to other sites.
Nice. I would love to revisit Big IP if we can figure out how to get one added to Data Center Dude's data center back here. I could certainly put it through its paces, and already being familiar with it. If you got one laying around, Steve, let me know.
Yeah, well, one of the cutting edges for Big IP is running it on DPUs. So running it in a Kubernetes environment. So it's a microservice on DPU technology. So NVIDIA would obviously be one that we came to market with recently. So
there's a virtual version of it too, right?
Hardware that's already on there.
There's a virtual version of it too, right? You can run it as a VM.
Absolutely. Yeah, it's been around for many years. It's called VE Virtual Edition. So I guess it would be analogous to ONTAP Select.
Yeah.
Yeah.
Awesome. Well, guys, this has been amazing. Thank you so much. I really appreciate the time today and all of the demos and the thoroughness of it all. If anybody, we didn't have many questions come in today, but I think this is one of those topics that tends to creep outside the scope of our typical audience of ONTAP and hardware. But I love that we've got this out here on the channel for anybody that can come and look for this stuff. For anybody that might be looking for solutions with F5, they'll likely stumble across this video. But yeah, thank you for all of the time today. Look forward to having you back, and look forward to seeing you at Insight.
Great. Thanks a lot.
Win, thank you as well, as always.
Thank you.
All right. Well, that's it, guys. That's our show for today. Thank you so much for joining us. We really appreciate it. If you have any questions about this, check the description below. We're going to leave some links. Make sure you come and join the Discord community over at netappdiscord.com. Just click join, sign up. If you're already in Discord, it's a quick join. Walk through our onboarding, make sure you get set up the right way. But we have almost 6,000 people in there now. It's crazy how that's grown over the last couple of years. Last reminder, get registered for Insight. It's happening. And you've got till the end of June to take advantage of a $300 discount off of your registration for early bird registration. Goes up in July. So don't say I didn't tell you. We'll be back soon with more stuff, but until then, my name's Nick Howell. Thank you so much for joining us, and we will see you guys next time. Take care.